chemical families, structure and bonding, properties across period 3, salts, effects of an electric current on substances, and finally, carbon and its compounds. The content is enhanced by the use of photographs, illustrations, animations, and videos. You'll be expected to attempt all the activities in the CD to ensure that concepts are well understood. In this topic, we will discuss the structure of the atom and the periodic table. In Form 1, an atom was defined as the smallest particle of an element that takes part in a chemical reaction. In this topic, we will discuss the structure of the atom. An atom is made up of 3 subatomic particles: electrons, neutrons, and protons. The central part of an atom is called the nucleus. The nucleus consists of protons and neutrons, and the nucleus moves around the energy levels. Protons are positively charged, electrons are negatively charged, while neutrons are neutral. Electrons surrounding the nucleus occupy regions called energy levels. For the first 20 elements, the first energy level takes a maximum of 2 electrons, second energy level a maximum of 8 electrons. The third energy level takes a maximum of 8 electrons. Electrons always occupy the unfilled energy level nearest to the nucleus. When an energy level is full, the remaining electrons occupy the next energy level until it is full. Lithium has 3 electrons. 2 electrons occupy the first energy level. The third electrons occupy the second energy level. Sodium has 11 electrons. 2 electrons occupy the first energy level. 8 electrons occupy the second energy level. 1 electron occupies the third energy level. Calcium has 20 electrons. 2 electrons occupy the first energy level. 8 electrons occupy the second energy level. 8 electrons occupy the third energy level, while 2 electrons occupy the fourth energy level. The electrons in each atom are arranged according to the maximum number of electrons in each energy level. For example, the arrangement of the electrons as 2, 1, 2, 8, 1 and 2, 8, 8, 2 is referred to as electronic configuration. The electrons in each atom are arranged according to the maximum number of electrons in each energy level. Isotopes are atoms of the same element which have the same atomic number but different mass numbers. The illustration below shows the isotopes of lithium atom. Identify the number of protons and neutrons in each isotope. The following illustration shows the isotopes of helium. Note that the isotopes have the same atomic number but different mass number. The relative atomic mass is the number of times an atom of an element is heavier than 1/12 of carbon-12 atom. 1 atom of carbon weighs exactly 12.000 atomic mass units, or AMU. The table below illustrates relative atomic masses of different atoms. The relative atomic mass is calculated as the sum of the product of the isotopic masses and their fractional abundance or percentage abundance. Click on the following animation to view how to work out the RAM. Examples of relative atomic mass calculations. The element boron consists of two isotopes, boron-10 and boron-11. Calculate the relative atomic mass of boron. Chlorine consists of 75% chlorine-35 and 25% chlorine-37. Calculate the relative atomic mass of chlorine. Click on the arrow to follow the method used. In this lesson, we will discuss the periodic table. Elements are grouped together based on the outermost energy levels. Elements with the same number of electrons in the outermost energy level form a group. Lithium is in group 1 because it has one outermost electron. Sulfur is in group 6 because it has 6 outermost electrons. Magnesium is in group 2 because it has 2 outermost electrons. Roll over the mouse on each of the first 20 elements to view their atomic number and electron arrangement. There are 8 groups in the periodic table. The groups are placed in a vertical column. Groups are indicated using Roman numbers. Elements between groups 2 and 3 are known as transition elements. Helium is in group 8, though it has 2 outermost electrons. This is because the first energy level can hold a maximum of 2 electrons. This means that the energy level is full and the element is stable. Elements in a period have the same number of energy levels. Type in electron arrangement of elements X, Y, and Z. In this lesson, we will discuss how ions are formed. In this lesson, we will discuss the period. Elements in a period have the same number of energy levels. Element X is in period 1 because it has 1 energy level. Element Y is in period 2 because it has 2 energy levels. Element Z is in period 3 because it has 3 energy levels. In the periodic table, each of the rows is called a period. Every element in the first period has 1 energy level. Elements in the second period have 2 energy levels, and so on. From the periodic table, the basic information about each element is given. In the symbol of the element, the superscript represents the relative atomic mass, while the subscript represents the atomic number. In this lesson, we will discuss how ions are formed. In a neutral atom, the number of protons is equal to the number of electrons. Group 8 elements have filled up outermost energy levels and are therefore stable. An atom, however, may lose or gain electrons in the outermost energy level. Sodium has electronic arrangement 2, 8, 1. For it to be stable, it can either lose 1 electron in the outermost energy level to have electron arrangement of 2, 8, or gain 7 electrons to have electron arrangement of 2, 8, 8. More energy is required to gain 7 electrons than to lose 1 electron. Therefore, it is easier for sodium to lose 1 electron than to gain 7 electrons. When sodium atom loses 1 electron, it will have 10 negative charges. The positive charges still remain 11. The net charge therefore becomes positive 1. Therefore, it is easier for sodium to lose 1 electron than to gain 7 electrons. Chlorine has an electron arrangement of 2, 8, 7. Chlorine atom has 7 electrons in the outermost energy level. It is easier to gain 1 electron to be stable than to lose 7. When chlorine atom gains 1 electron, it will have 18 negative charges. The positive charges will be 17. The net overall charge of the chloride ion is negative 1. Magnesium atom with electron arrangement of 2, 8, 2 will lose 2 outer electrons to form magnesium ion with electron arrangement of 2, 8. It is easier for the magnesium atom to lose 2 electrons than to gain 6 electrons. The magnesium ion formed will have 12 positive charges and 10 negative charges. The net overall charge of the magnesium ion is positive 2. Sulfur atom has 6 electrons in the outermost energy level. When it reacts, it gains 2 electrons to be stable, since this requires less energy than losing 6 electrons. Protons in the nucleus, which are positively charged, attract electrons which are negatively charged in the energy levels. For an atom to lose an electron, this force of attraction must be overcome. This is achieved by supplying energy to pull off the electrons. This energy supplied is called ionization energy. It is measured in joules. Ionization energy is thus defined as the energy required to remove an electron or electrons from an atom in gaseous state to produce an ion. Non-metals gain electrons to become stable since electrons are negatively charged. When an electron attempts to get into the outermost energy level of an atom, it will be repelled by the electrons which are already there. Therefore, some force is needed to move the electrons into the energy level. When the electron finally settles in the outermost energy level, heat energy is lost. The heat energy lost is more than that used to force the electron into the energy level. The net heat change when a gaseous atom of an element gains an electron is called electron affinity. When an atom loses or gains electrons, it becomes electrically charged. The resultant charged particles are called ions. Positively charged ions are called cations. Negatively charged ions are called anions. During chemical reactions, metals lose electrons and therefore form cations. Non-metals gain electrons and therefore form anions. The number of electrons an atom gains or loses is called its valency. For example, lithium atoms loses 1 electron and therefore lithium has a valency of 1. Sulfur atom gains 2 electrons and therefore sulfur has a valency of 2. Magnesium atom loses 2 electrons and therefore magnesium has a valency of 2. Some elements have varying valencies. For example, copper can have a valency of 1 or 2. The valencies of such elements are indicated in Roman numbers in brackets when naming compounds. The table below illustrates some compound and their valencies. Click on the arrow to view the valencies of different compound. A group of atoms that exist together and react as a unit with a net charge and which cannot exist on its own is called a radical. The valency of a radical is the same as the value of its charge. When an atom loses or gains electron or electrons, the charge on the resulting ion is referred to as oxidation number. Below are some oxidation numbers of some common radicals. Click on each arrow to view their oxidation numbers. In this lesson, we will discuss how to derive the formula of some simple compounds from valencies of elements and radicals. When two or more elements combine, they form compounds. Chemical formula is a short notation of writing names of compounds. It shows the atoms present in the compound. When writing the chemical formula of a compound, it's necessary to know the symbols and the valencies of the elements and radicals that form the compounds. Writing chemical formula using a game of cards. Sodium chloride. From the illustration, sodium has one projection since it has a valency of 1. Chlorine has one groove since it has a valency of 1. The two will fit and therefore the formula will be NaCl. Chemical formula of potassium sulfate. Potassium has one projection since it has a valency of 1 and sulfate has two grooves representing a valency of 2. Potassium fits in one groove of the sulfate and one will be left free. For it to be complete, it needs another projection of potassium. Note that we need 2 cards of potassium and 1 card of sulfate. The chemical formula of potassium sulfate is therefore K2SO4. From the illustration given, the chemical formula of calcium chloride is CaCl2. Formula of water. To write the correct formula, we must write: Step 1. Write the symbols of the elements. Step 2. Write the valencies of the elements above and to the right side of each. Step 3. Exchange the valencies by writing them below the symbols. Step 4. Write the symbols close together. Formula of carbon 4 oxide. Step 1. Write the symbols of C and O. Write the valencies of C and O above and to the right side of each. Step 3. Exchange the valencies by writing them below the symbols. Step 4. Divide the valencies by common factor 2 to represent the atoms in the simplest ratio. Formula of iron 3 oxide. Steps. Write the symbols of iron and oxygen. Write the valencies of iron and oxygen above and to the right side of each. Exchange the valencies by writing them below the symbols. Write the symbols close together. Fe2O3. The valencies have no common factor which can divide and give a whole number. Therefore, the number is just reversed. Therefore, the formula is Fe2O3. Formula of ammonium carbonate. Steps. Write the formula of the radicals. From the formula of the radicals, write their valencies above and to the right side of each. Exchange the valencies by writing them below the symbols. Write the symbols close together and put the brackets for the ammonium radicals. Brackets are written for ammonium since 2 ammonium radicals are combining with 1 carbonate radical. In this topic, we will discuss how to write chemical equations and balance them. Magnesium reacts with oxygen to form magnesium oxide. The following is the procedure of writing a balanced chemical equation. Click on each box to follow the procedure. Write the correct word equation for the reaction. Write the correct chemical formula for each of the reactants and products. Balance the chemical equation by counting the number of atoms of each element in the reactants and in the products. Check whether they are equal. Include the state symbol of all the reactants and products. There are 4 physical states: solid in bracket S, liquid in bracket L, gas in bracket G, and aqueous in bracket AQ. The aqueous state means dissolved in water. The physical state of each reactant and product is written in brackets. Sodium granules react with oxygen to form sodium oxide. The following is the procedure of writing a balanced chemical equation. Click on each box to follow the procedure. Write the word equation for reaction between sodium and oxygen. Step 2. Write the equation using correct chemical formula of reactants and products. Step 3. Count the number of atoms of reactants and products and check whether they are equal. Sodium atoms are now equal, 2 on the left and 2 on the right. Oxygen atoms, however, are not equal. There are 2 on the left and 1 on the right. To make oxygen atoms equal, we insert 2 in front of sodium oxide and count the atoms again. Sodium atoms are now equal, 4 on the left and 4 on the right. Oxygen atoms are also equal, 2 on the left and 2 on the right. The equation is now balanced.